All right, so let's do a few more simplify radical, okay? But this time we're going to use number because earlier I've used variables to do it, okay? Radical expression, okay? So let's say if we had to simplify square root of 18, which is just a number. So what we would have to do is to break down the number 18, right, with the factor tree that we've learned, okay, divided by 2, that would give us 9. 9 is 3 and 3. Well, we have a pair of 3 within that as factors. So technically, this is square root of 2 times 3 times 3, because that's what 18 is. The same thing. So when we notice that we have a pair of 3, that means we can bring out a 3, bring a 3 to the front. Okay, so it would be 3 square root of 2. That is the answer to simplified square root of 18. Let's simplify now square root of, well, 5 and then square root of 20, for example. Okay, so the 5 is fine the way it is right now. We just have to break down the 20, dividing it by 2, that would be 10. Divide 10 by 2, that would be 5, right? Which is the same thing as saying 5 square root of 2 times 2 times 5. Okay, so all those are prime numbers. Okay, well, we have a pair of 2. 2 times 2. So because we have a pair, we pull 1, 2 out. So what we end up having is 2 times the 5 that we already have out, square root of 5. So when you bring it out, then you have to multiply it. 2 times 5 becomes 10, square root of 5, and that would be the final answer right here. We'll do one more real quickly with numbers and variable, which we did, I believe, a few in one of the previous video that we posted, but we're going to do another one. Let's say if we had a 2x squared, right? If we had 2x squared, y, and then square root of 50, okay, x to the 4th power, y fifth, and then z. So if we had that, then whatever expression we have outside of the square root is fine, but the ones inside of the square root is what we have to worry about. So if we had to break that down and under the square root, we would have to simplify 50 or break it down to the factor tree. Let's say if we take 50, we divide it by 2, it would be 25, which is basically 5 and 5. Okay? So then what we end up having is this. So we know 2, 5, and 5 is what gives us 50. So let me erase that. Let me erase that now. So we write 2x squared y, and then square root of 2 times 5 times 5. That's 50. Okay? 25 times 2, that's 50. And then with the x, technically x to the 4th power, that's x, 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 x. 1, 2, 3, 4, x. And for the y is 5y. Or y, not 5y. It's y 5 times. So y times y times y times y. 1, 2, 3, 4, 5. But it's not 5y. It's actually y to the 5th power. That's what that is. And then z. So what this is telling us, every time we have a pair of something, we can pull it out. So we can pull out a 5. We can pull out x once. We can pull out x twice. We can pull out y once. We can pull out y twice. We cannot pull out y an extra time because there's only one additional y left. Z is by itself. We cannot pull it out. So then what we can do is pull out the 5. So now we end up having 5 times 2, the 2 that was out here, x squared, or let's not say x squared, okay, let's just say the 2, because we can pull out x once, x twice, so we can pull out x squared. So since we can pull out x squared and we have an x squared out here, then it would be x squared times the x squared that we're pulling out from under here. And then for the y, it would be y times the y squared that we're pulling out from in here. So what is left? Square root of this 2, it stays because there's nothing we can do with it. So the 2 stays, and then this y stays, and then the z stays. This is the y that stays, and this is the z that stays. So now we pull out everything that we had to pull out, but once they're out here, we have to combine like term, or in other words, we have to basically multiply whatever that are the same thing. So 5 times 2 becomes 10 in the outside. X squared times x squared becomes x to the 4th power in the outside. Y times y squared becomes y cubed in the outside. And then square root of 2yz, that would be the final answer for the simplification. Okay, so that's it for simplify